So in this video, I'm going to go over the review for the 10.1 through 10.3 quiz, starting with the directions for the first three questions. It says, write the slope-intercept form of the equation of the lines described. It says through the point -2, 5. So what we're going to do first is we are going to find the slope of this line. If you recall, the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So we notice here that our slope is 1/5, so m of this line is 1/5. And then the perpendicular slope of that is the negative reciprocal number, and then we're going to flip it. So our perpendicular slope is going to be -5, because the flipped version of 1/5 is 5/1, which is 5. Then we're going to use that in the equation y equals mx plus b, new y-intercept is. So to do that, we're going to plug in our x and y here. And we're going to use our m that we're given up there, and we're going to solve for b. So we're going to have 5 is equal to 1/5 of -2 plus b. Again, remember, we're going to solve for b here, and we're going to plug it back in the equation with m and b to get the equation for the line. So this is going to be 5 is equal to -2/5 plus. Now, when I try to combine these terms, I'm going to I'm going to multiply the top and the bottom by 5/5, 5/5, and I'm going to add to it the 2/5 because I'm moving it to the other side of the equal sign. So that's going to give me 27/5 for my b. Now, once again, I'm going to plug back my b and my m up here into the equation for a line. So this is y is equal to 1/5 x, and then we're going to put this b back up there, so that's going to be 27/5. So we're going to do this process over and over again to find the perpendicular and parallel lines through the given point. So here again, we're going to do y equals mx plus b. We're putting in our x and y values. So we got 5 here is equal to, now our perpendicular slope is going to be -5. So let's give 2 plus b. So 5 is equal to 10 plus b. When we subtract 10 from both sides, we get that our b is -5. So here again, we're going to put this in the equation, y equals mx plus b. So y is equal to, again, we're plugging in our m here, the -5, so that's -5x plus the b that we just solved, which was -5. We're going to do this process a couple more times with number 2 and 3. So here again, this time, however, we have to get this equation y equals mx in this equation in the y equals mx plus b format. So what I'm going to do first is I'm going to move the -x to the other side. So that's going to give me x plus 20. And then I'm going to divide everything by 5. And remember, there's a 1 up there, so that's going to end up being 1/5. So my equation now is y equals 1/5 x plus 4. So here again, we need to talk about what is our parallel slope and what is our perpendicular slope. Well, our parallel slope is the same, so m equals 1/5, and then our perpendicular slope is going to be the negative reciprocal of that. So that's just like what we did before. That's going to be -5. That's like the problem we did previously. So here again, we're going to do y equals mx plus b. Going to take our x and our y from right there, and we're going to pull our slope from the parallel and perpendicular slopes. So we've got 0 equals 1/5 times 2 plus b. So this is going to be 0 equals 2/5 plus b. So we're just going to subtract the 2/5 from both sides. So b is equal to -2/5. So now once again, we have our slope up here of our parallel, and we have our y-intercepts. We're going to plug those into the equation. Y equals 1/5 x minus 2/5. Now we're going to do it with a perpendicular line, again using that same equation, y equals mx plus b. So we're going to plug in again the 0 equals our slope. This time our perpendicular slope is -5, and we're going to multiply that times 2 plus our b. So this is 0 equals -10 plus b. Going to add that 10 to both sides. So this time our b is equal to 10. And here again, we're talking about our perpendicular slope, which is -5, and our y-intercept, which is 10. So y equals -5x plus 10. So with number 3, again, we're going to have to do the similar first step. We're going to have to get this in y equals mx plus b format. So this time all I have to do, though, is move the 4x to the other side. So again, my parallel slope would be the same slope, so that's -4. My perpendicular slope would be a positive, and then 4 is the same as 4 over 1, so this is going to be positive 1/4. Okay, so once again, we're going to do y equals mx plus b, and we've got our x and our y here, so we're going to say 2 equals our -4, that's our parallel slope, times our 5 plus b. So 2 is equal to -20 plus b. I'm going to add the 20 to both sides, so b is equal to 22. Once again, we're just going to plug in our y-intercept and our slope. So y equals -4x plus 22. Our other one over here, again, y equals mx plus b. So here again, this time we're going to plug in our 2, and our slope this time is 1/4. And we're going to multiply that times 5 plus b. So here again, we're going to have 2 equals 5 over 4 plus b. Again, I'm going to do what I did previously, and I'm going to multiply the 2 times 4 over 4 to get a common denominator. So that's going to give me 8 over 4. 8 divided by 4 is 2. And then we're going to subtract that 5 over 4 from it. That's going to equal our b. So b here is going to be 3/4. So once again, we're going to plug in our y-intercept and our slope. So y equals 1/4 x plus 3/4. Now we're going to move on to number 4. It says in segment RT, S is the midpoint. If R is 6,1 and S is 3,5, what is T? So this question is asking us to find another endpoint when we're given the midpoint and one endpoint. So first thing we need to do is recognize that. And we're going to use our midpoint formula on this one. So that is x1 plus x2 divided by 2 equals our midpoint. And y1 plus y2 divided by 2 equals our y value of our midpoint. So we're going to use these formulas to solve this problem. So we've got, and I'm going to call this x1, y1, and this xm and ym. So when I do this, I'm going to have 6 plus x2 divided by 2 is equal to 3. We're going to multiply both sides by 2 to get rid of the 2 in the denominator. So that's 6 plus x2 equals 6. When we subtract the 6 from both sides, we see that x2 is equal to 0. Over here, same process again. We're going to say 1 plus y2 divided by 2, that equals our 5. Going to multiply both sides by 2. So 1 plus y2 equals 10. Going to subtract the 1 from both sides. So y2 is equal to 9. So our point T, which is what we're looking for, is 0, 9. And this is another endpoint, remember. So with number 5, it says, what is the perimeter of ABCD and what is the midpoint of the diagonal? So this is a question that has two parts to it. So we're going to first find the perimeter of ABCD by finding all the sides. So what I want to do first is show you what ABCD looks like, or what I think it looks like. So A, B, C, D. Now the reason I do this is because then I know which sides I need to solve for. I need to solve for AB, BC, CD, and DA. So that's what I'm going to do first. So when I solve for AB, I'm going to use the distance formula because I'm trying to find the length of each of the sides. So I'm going to take my values, and I would call this x1, y1, x2, y2. So I'm going to put these into the equation like that. So that would be 5 minus 2 squared plus -3 plus 1 squared. I'm going to then simplify that. So I get 3 squared plus a -2 squared. And remember, anytime you square a number, it becomes positive. So this is going to end up being the square root of 9 plus 4, which is equal to the square root of 13. And I'm just going to leave it like that for now till I find them all. And then we can decide what we want to do with them. Then we've got BC. Again, I'm going to call this this time x1, y1, the 5 and the 3, x1, y1, and the 7 and the 0, x2, y2. So let's do this one now. It's going to be 7 minus 5 squared plus 0 plus 3. Now I said plus 3 because it's minus a minus 3, and that's what's going to make it a plus 3. And I didn't explain that on the step above, but that's why it's plus. Now this is equal to, again, 2 squared plus 3 squared. That's going to be equal to 4 plus 9, which again is the square root of 13. Then we've got CD. CD is equal to, again, we're going to talk about x1, y1, x2, y2. So that's what we're using in this one. So this is going to be 4 minus 7 squared plus 2 minus 0 squared. That's going to be equal to, again, a negative 3 squared. And recall, once again, that when we square any number, it becomes positive. And then this is going to be 2 squared. So that, again, is going to be equal to 9 plus 4, which is the square root of 13. Then we have dA. This is our last side. So on this one, same process. We would have made D x1, y1 and A x2, y2. So here we've got 2 minus 4 squared plus 2 plus 1 squared. That's going to be equal to negative 2 squared plus 3 squared. That's equal to 4 plus 9, and that's the square root of 13. So when we try to find our perimeter, what we're going to do is we're going to basically add all those together. Well, in this case, because all of them are the same, we can just say 4 times the square root of 13. So at the very least, we know that this shape is going to be a rhombus because it has 4 congruent sides. So when we multiply 4 times the square root of 13, we get 14.4. That is the perimeter of my shape, ABCD, which we know is a quadrilateral. Now, the next part of this question asks me what is the midpoint of the diagonals. Well, I have to know what the diagonals are. So I'm just going to draw a line from A to C because that's my diagonal. So I need to find the midpoint of that. So when I'm looking for the midpoint, if you recall, we're going to use the equation x1 plus y1, x1 plus x2 divided by 2. So when we're talking about the midpoint of AC, we're talking about this point and this point. So we're going to do 2 plus 7 divided by 2, that's 9, divided by 2, that's 4.5, so that's my x value. Then we're going to do the y values, which is going to be negative 1 plus 0 divided by 2. Well, that's negative 1 over 2, which would be negative 0.5. So our midpoint of the diagonal is 4.5, comma 0.5. So with number 6, it says, if the endpoints of the diagonal of the square below are negative 4, negative 5, and 1, 0, what is the length of the diagonal? Well, I'm just going to put these on here where I think they would be negative 4, negative 5, and then up here 1, 0. So it's asking us what is the length of the diagonal. Well, obviously we're going to use the distance formula to find that. So the length of the diagonal is going to be, again, I'm going to make the negative 4, negative 5, x1, y1, and then I'm going to make the 1, 0, x2, y2. So I got 1 minus the minus 4, so that's going to be 1 plus 4 squared, plus 0 minus the minus 5, which is going to be plus 5 again squared. So this is going to be 5 squared plus 5 squared, and that's going to be 25 plus 25. So that's going to be the square root of 50. Now I can simplify that to simplest radical form, and I'm going to show you why I'm going to do that in a minute, but that's going to be the square root of 25 times the square root of 2, which is equal to 5 square root of 2. Now I can also find out what that actual length is, and we're going to need that to find the area of the circle because that's the next part of this question. It says now find the area of the shaded portion of the drawing to the nearest hundredth. So this would be 7.07. So it says find the area of the shaded portion of the drawing to the nearest hundredth. Well, to find the shaded area, I have to find the area of the circle and then the area of the square and subtract the two of them. So what I'm going to do is find the area of the circle. To do that, I have to get the radius. Well, I have the diameter right now. The diameter is equal to 7.07, so the radius is going to be that divided by 2. So that's going to be 7.07 divided by 2, and when I did that, I got 3.54. It also says that we need the area of the square, so I'm going to draw up here what we have. We have the diameter right now, and that's 5 square root of 2. Well, I recall that this type of triangle right here is a 45, 45, 90 triangle. And if you guys remember, the formula for the hypotenuse of a 45, 45, 90 triangle is the leg times the square root of 2. Well, we want to find this leg, and we know that they're congruent. So that would be 5 square root of 2 equals the leg times the square root of 2. Divide both sides by the square root of 2. So our leg would be 5. Right? So that means this is 5 and this is 5. That's going to help us find the area of our square in a minute. Okay, so let's move on. We're going to find the area of the circle. So the area of the circle is equal to pi r squared. So that's going to be pi times 3.54 squared. When I did that, I got 39.27. Now I want to find the area of that square. Well, the area of a square is just equal to the side squared, right? So that's equal to s squared, which is equal to 5 squared, which is equal to 25. So what are we going to do with these two measures to find the area of the shaded? So the shaded area, shaded, S-H-A-D-E-D, yeah, shaded area is going to be equal to the area of the circle minus the area of the square. So that means we're going to take the 39.27 and we're going to subtract from it the 25. So my final answer for the shaded area is equal to 14.27, and these are going to be units squared because again it's area. Number 7 says, what is the point that is 2/3 from M to N on the directed line segment MN? Okay, so when we're talking about this problem, first thing we need to notice that we're given the value as a fraction, and that means we're going to use the formula x1 plus a over a plus b times x2 minus x1. So that's going to be our x value, and then our y1 plus, again, a over a plus b, and that's going to be y2 minus y1. Okay. So we're just going to plug our values in. Now, this is our a over a plus b. We don't substitute anything in. It is that. And then we're going to make this our x1, y1, and this our x2, y2, and plug all that stuff into the formula and see what we get. So our x1 was -5. Our fraction is 2/3. Our x2 was 10, and then we're going to subtract from it a -5. So remember again, once we subtract the negative, we're actually adding. So this is going to be -5 plus 2/3 of 10 plus 5. So that's going to be -5 plus 2/3 of 15. So remember PEMDAS, we always do what's in the parentheses first, then we're going to multiply. So we're going to take 2/3 of 15, and you can do that on your calculator. You can multiply 2 times 15, which would be 30, and divide that by 3, which is 10. So this is going to be -5 plus 10, which means this point is going to be 5. Over here, solving for our y value, again, so we're going to have y1, which is -8, plus, again, our 2/3, we're just subbing in that fraction. y2 is 10, and again, we're going to subtract a negative, so that means we're going to actually add it. So this is going to be -8 plus 2/3 of 10 plus 8, negative 8 plus 2/3 of 18. 2 times 18 is 36, and 36 divided by 3 is 12, so this is going to be negative 8 plus 12. So this value is going to be 4. So our answer is going to be 5, 4. Last problem, number 8, says find the coordinates of the point that partitions a line segment AB is 1/5 from A to B. Okay, so on this one, we're going to use the formula B times x1 plus A times x2 over B plus A. That's going to be our x value of our point for our partition line segment. And then over here, we're going to be by1 times y1 plus A times y2 over again B plus A. So what are we talking about here? Well, this is going to be my A and this is going to be my B. This is my x1, my y1, my x2, and my y2. So that's what I'm plugging into the values. So I have B is 5 times my x1 is negative 10 plus A is 1 times my x2, which is 8. Then we're going to add the B to the A, so that's going to be 5 plus 1. So I'm going to go ahead and multiply on top. So that's going to give me negative 50 plus 8, and I'm going to add on the bottom, which is going to be 6. So when I do negative 50 plus 8, that is going to be negative 42 divided by 6. Well, that actually is negative 7. So that's going to be my x value of my directed line segment, the coordinate of the point. So the x point. So then with B, we're going to again do 5, that's my B, times y1, which is 12, plus A1 times my y2, which is negative 12. Again, going to do our B plus A, so that's 5 plus 1. So this is going to be 60 minus 12 divided by 6. 60 minus 12 is 48, so 48 divided by 6, that is 8. So our point value, when we're all said and done, for our directed line segment is going to be negative 7, comma, let me move this, 8.